Hi, good morning. Today is November 29th, 2025, and my name is Rinaldo J. Aguiar Marcano. I'm recording this video from my home located at the 2302 Britton Ridge Drive, Katy, Texas 77494, the United States of America. And this house is located on a gated community called Lake Point Estates in Katy, Texas. And this is relevant because this is an important neighborhood of the network that I've been documenting in this series of videos. It's an important control center. It's an important hub. And my house specifically is located 300 feet away from the house of a gentleman by the name of Robert S. Mueller III. And he was the director of the FBI, so the American Intelligence Services, for several years ago. And this is relevant to this conversation. So good morning. Today is Saturday, as I said, November 29th, 2025. And this is demo D92. But chronologically speaking, this demo is being recorded right after the demo D1998. And that one had a special designation for these reasons that are explained in that video, in that demo. So the goal of this demo 92 is really more than a demo. It's designed to be more like let's call it a training session. Okay. So the idea that I have with this is to pass to you things that I've learned on how to defeat the network interception of the Communist Chinese, the Communist Party of China, right? The CPC. Which are they are the people that at the end are doing all this have been doing this for decades, right? So the goal of this demo really is to transfer knowledge, right? That I've developed by years of observation and witnessing and receiving this, right? So my thinking is, since I've spent all this time, right, it took me all these years to figure all this out. I mean, what I'm going to mention in this demo, like this is not something that I learned last week, right? Like this is knowledge that I've been refining over years of observation, right? And thinking about how to defeat this. So given that I've done that, right, and I've gone through that process, I figured I might give you the information, right? So you don't have to spend years trying to figure it out, right? And I'm talking directly to individuals that might be targeted by this network, right? If you are, I don't know, the FBI, you probably can figure this out, in a matter of a week, right? Because you have more resources. But if you're an individual, right, being targeted by the CPC, and you don't have the resources of the FBI, I'm going to tell you here how to circumvent what they do. So that's objective number one. Objective number two is more high level, right? And this comes from the angle of, one, me being a witness of this, right? And secondly, me having had the experience of being employed by the network in key engineering positions at Google, right? Where I was exposed to, high tech. And in that process, I developed an understanding of how the internet works, through all the stack, but not only from the technical point of view, but also from the standardization point of view, right? So I have understanding of how the W3C works, for example. I know people that at Google, I met people that work with the W3C, right? So this is a committee that standardizes the protocols that make the internet work. And this is relevant because ultimately, right, the goal should be to transfer these learnings to, I don't know if it would be the same organizations, right? Because those organizations, and I can tell you this based on the data that I have, that Diosdado Cabello leaked to me, those organizations are deeply compromised, right? The organizations that govern the internet. I don't know if govern is the right word because it's really a territory that is unregulated, but the committees that standardize things on the internet, those committees are heavily under the control of the network, and that's part of the problem, right? So when they create the protocols come designed with these weaknesses that the CPC exploits, right? So I don't know, right? That's beyond my, my that's outside my circle of influence, right? So I don't know what will happen, right? It could be either that those committees are improved, or it could be that they're replaced, right, by something that is more difficult to attack in this way. But either way, right, whatever happens, there needs to be a fundamental change on these protocols, right, to fix all these weaknesses, because otherwise the problem will continue, right? So as I mentioned in demo 1998, they go for the aggregators, right? And they what bigger aggregator on the internet than the protocols themselves, right? So that's why they attack the protocols. So the protocols need to be fixed, right? That's the end solution to the problem, fixing the protocols. That way they cannot attack anything, right? So you can apply, what I'm saying is, I think the world needs to apply the same philosophy that they use to attack everything, right? But to fix things, right? So fix the aggregators is a solution, right? Or, you know, replace the aggregators and create intentional fragmentation. Like that's the other solution. Or maybe both, right? That's why I was saying in the previous demo in 1998, chronologically speaking, the demo before this one, that in the case of the payment systems, the solution might be a combination of fragmentation with standardization to replace globalization and monopoly, right? Monopoly control. So yeah, so that's the idea of this demo, right? But before, so I guess I'm gonna split this demo into two parts, okay? So it's going to be, the bigger part of the demo is gonna be part two, which is gonna be more technical, heavily technical, I would say. I would go into details on how these things work. I mean, what they do, right? But the first part, I want to take a moment to, to kind of clarify a few things, or to kind of, no, I don't know if clarify is the right word, but qualify some of the things that I said on demo 1998. Because I was doing QA on the demo, and I see, right, I said some things that, if you're coming cold into this and you hear this, it might cause some noise, right? Because it has some comments that might be read as politicals, but they're not really political comments, and I want to, elaborate more on that. So I have a list of talking points of things that I want to say about, it's kind of, let's think about the part one of this demo as a continuation of demo D 1998. And then the second part is going to be the fully technical part, okay? And in the second part, I'm going to go deep into the attacks and how they do it and everything, right? And how I can, or how I have been able until this point to circumvent some of these things, most of these things. Right? So the first thing I want to say, right, is that on demo 1998, I made a comment and I said, that the Communist Party of China is doing this, right? I want to say that I'm saying that based on the data that it's in this leaked database that the agents of Teodoro Cabello leaked to me last year, right? But I see, right, that if somebody's coming cold into this, there is a possibility that somebody could say, well, this is a political statement, or there's a political agenda. And what I want to say to people that may think that way is that just because they have the word communist in the name of the organization doesn't make it a political issue. Right? It's just a name, right? And in fact, I'm going to say some things in a few minutes that you will see that this is not really, even on their side, it's not a political stance, right? This is they are really, in my opinion, they are a terrorist organization. Why? Well, because they target children. They intentionally harm children to, get people out of the way. They target civilians with, viruses and things. And, all this is documented in the books. I don't want to go into much detail into the things that they do, but if you read the book, you will see that they fit the definition of, and I'm talking about the CPC, the Communist Party of China, right? So independently, if they have the word communist in the name, I believe what they really are a terrorist organization. That's what they are. And it has nothing to do with having communist in the name. In fact, think about it this way, right? There are religious groups that are considered terrorist organizations. Just because they have a religious name in their name doesn't give them the protections of a legit religious group, right? If they're committing terrorist acts, they should be treated as terrorists, right? I want to say something, right? And I said this before, during this conflict, there are certain avenues by which I could recover money from them, right? Where I could, get rewards for information or things like that. I want to explicitly say my intention is every penny that I get from that, I'm going to spend it into lobbying for getting them recognized as a terrorist organization, because that's what they are. So that's the first thing I wanted to say, right? The second thing is about, I made a comment about, a proposal was really, right? Estatizing the online payment systems, right? In each country, right? To create fragmentation and destroy the monopoly. Right? And I see certain risks that people could say, well, but this is not the business of a government. But I want to explain why I said that, right? Why I'm proposing that. It's not so much about making a state business, making it a state-control operation. When you think about estatization of something, it doesn't necessarily mean that the government owns it. Like, there's different avenues to do this with different degrees of estatization, right? There's situations in which the government outright performs the whole operations. There are other situations in which the government could. I'm talking about a generic government, right? A generic country. I'm not talking about any specific government. But there are situations which could be considered estatization, in which there's still a private entity involved, but the thing is heavily regulated, with a very tight leash, right? So I don't know, right? I don't know what would be the best balance there. But it's obvious to me that this has to be something done by a government. This cannot be done by an entity controlled behind the scenes, or a set of entities controlled behind the scenes by the CPC. Oh, before I get into this, let me tell you something. In the Geo Index, because I was mentioning about the terrorist organization, in the Geo Index, there are, and, I will show this to the authorities. There are markers in that database, genetic DNA markers, right? Genetic markers and this is something. It's a hypothesis, right? I can prove this, but well, first of all, I think authorities should investigate this, and secondly, I can put two and two together by looking at the reports from the United Nations and things like that, where the Chinese government and the Communist Party of China have been accused of doing organ harvesting, right? So in this database that they use for everything, there are markers in which they're marking DNA markers of people that are obviously rich people and of people that are obviously very poor people, right? My hypothesis is that this is a matchmaking process between potential donors, right? Donors, quote unquote, right? People from which they could potentially harvest organs, and people that could potentially need those organs, right? Because they have a chronic illness or whatever, right? Again, this is a theory, but this is something that authorities should investigate. And I wrote this in the website at some point, and what they did is that the next day they de-indexed the entire page from Google, right? And this is also documented in the books. So, like, harvesting organs from living human beings is what it is. If this is not what a terrorist organization does, I don't know what would be, right? Like, I cannot think of any, I cannot think of anything that is more horrendous than harvesting organs from and to give the full context, like, look this up. There's been multiple reports to credible organizations, the United Nations, and where they've been accused of harvesting organs from practitioners of the Falun Dafa, right? So this is a religious group, and so so what they do is that they target their adversaries, and besides getting them out of the way politically, then they also harvest the organs, right? So anyhow, back to the topic of the payments, right? So what I was saying is that, yes, so people could say, well, this is the payments, right? It's a commercial thing, like If you think about that way, you could make that argument, right? But think about it this other way. Because of the digitalization of payments, we're talking specifically about online payments, right? Full control over that industry via an undeclared monopoly, which is the CPC is doing, right? That implies full control over the currency system. Now the currency is digitalized, right? This is still US dollars, but they're all in digital form. It's not paper money, it's digital, right? And because if you compare the volume, I guess what I'm trying to say, compare the volume in the US, for example, of digital transactions versus paper transactions, paper money transactions, you will see that the difference is immense, right? I don't have the numbers, but it's obvious to me, right? So obviously, the control over currency has always been the business of the government until now, right? Now, because it's digitalized, all the transactions happen digitally. The control of the currency is, in practice, right, de facto, is being done by PayPal and all these companies that are controlled by PayPal and by proxy by the CPC. Right? So that's the reason why it needs to be statized, right? Because it's the only way to assign back the responsibility over currency control to the government, right? Where it should belong, right? It's not a business of the Communist Party of China to control the currency system of the US. I mean, that this is a crazy thing, right? To think that it's okay to allow this to happen. And another thing I want to say is that, if you're thinking about, well, but this is sounding a lot like a political conversation. It's not, right? And you can see this clearly here. All these, I'm going to talk about, countries that call themselves communist. I don't think they're really communist because you can see, right, the leaders of this, I'm going to talk about a country that I know very well because I was born there and I spent years of my life in that country. The leaders of that country, they talk about communism, but they live like rich capitalists, right? Like they live in mansions and they drive, expensive cars, and so they don't really believe in that thing that they're saying, right? But beyond that, right? If you look at it purely from the perspective of estatization versus privatization, right? You see what they're doing, right? In their countries, they staticize everything, right? All the industries, for example, in Venezuela, all the important industries are controlled by the government completely, like are owned by the government, right? So the oil company, right? The steel industry, like all those sectors are monopolized by the government. Like it's not possible to get a permit in Venezuela to extract oil from the ground. It's impossible, right? If you are not an entity of the government. But right, so these countries, right? The countries that are doing this really, they staticize everything within their countries, right, to keep control. But then they create these commercial entities in other countries like the US, like PayPal, and they push for privatization of everything, right? In the ways that I already described in Demo 1998, right? By weakening the governmental systems and then proposing a technical solution that is much better, right? And abolishing the regulations, right? And I gave 4 examples in Demo 1998. So you see the contradiction there, right? So they believe on one thing internally, but externally they push for the opposite. And the reason is because they realize that privatization is a weapon, right? Because commercial entities have a lot of protections, right? They can do a lot of things. Like, for example, changing the location of a house in Google Maps, right? Google will say, right, if they're challenged legally, they will say, well, this is our database, and we can do with our database whatever we want, right? They have no accountability to anybody about what they put in that database because they're a commercial entity. But if they were a government entity, they would be accountable, right? They could not lie about where the house is, right? If they were a government entity. So that's why all these governments promote privatization outside of their countries. But in their own countries, they promote estatization. So beyond the argument of which one is better, not going to get into the argument, but what I want to show you is the deep contradiction in their own philosophical system, right? And that shows you that this is not a political issue. It's not an issue of communism versus capitalism. It's not. Right? The issue is how they're using the protections that commercial entities have and weaponizing those protections to spy and to steal technology and do things in other places that are not their own country. Right? So I just wanted to, clarify those things. Another thing I wanted to say regarding to the demo 1998 is that after the fact, right, I was thinking, okay, so I found 4 verticals. How can I find more? And it occurred to me that it's easy, really, like because the pattern that we saw in demo 1998 was that all these things were things that all the countries were doing, right? So that, I mean, and that there's a deeper meaning in that. That means that it's something that is so fundamentally necessary that every country had to do it, right? Because think about it, if it's not something that is, a must-have for a country, there might be certain countries that might elect not to do it, right? So, for example, let me give you an example, right? The taxi cab industry. If that wasn't a necessary thing, you would observe that out of all the, say, 180, I don't know how many, depending how you count it, right? Because there's some territories that are disputed, and the Tibet, for example, right? It's a country, it's not, I don't know. But if it was not a necessary thing, a necessary utility, then you would observe that some countries don't have taxis, for example, right? But the fact that every country has taxis means that it's a needed, right? It's a needed resource, that it's a must-have for a country. And that, therefore, that's why they attack it, because that would give them, that would open, if they control it with a global solution via technology, that would open the door to every single country, right? So they don't convert it. They exploit the fact that if it's globalized, it becomes an aggregator, right? And then they can attack it and exploit it, right? Because ultimately what they do is to exploit the aggregators. So that's a way to identify other things where they have done the same thing, right? So I started thinking about things that that are global, that existed in every country before 1998, right? And that's why I named the demo 1998, right? Because I think that's the year where everything went downhills, right? In terms of freedom, right? Because they took control of the internet in this way and nobody noticed, right? Because it's unregulated, right? And it's not fragmented, right? Like if there were 180 internets, one in each country, right? It would be a lot more difficult for them to control the whole internet, right? But anyhow, that's an interesting thought. Anyhow, yes, so I started thinking about things that before 1998 were things that were needed in every single country, right? And that after 1998 became standardized globally through the means of technology. And there's a lot, but I'm going to mention 3 or 4 that I found very interesting, right? One is very recent, is the digital passports. I don't know if you've seen this push in multiple countries, and I've seen this in Canada, in the US, in Europe, I imagine in other countries as well. There's a push for digitalizing the passports. And of course, because governments individually, right? Governments are usually slow, right? And the reason why they're slow is not because they're dumb, it's because they play it safe, right? Because if you cannot make a decision that could harm your population, right? You're accountable to them. And there are political pressures, there are other things. But the fact that governments are slow or slower, right? That gives an edge to the network to justify or to be able to produce solutions that are really very far ahead technologically, right? And then the immediate thing is, okay, let's adopt that solution, right? I explained that in the previous demo in 1998. And so I imagine, right? Imagine that you want to create digital passports, really, right? For the entire planet. There's no single government in the world that will have a solution ready to go right now for this. Right? It doesn't exist. A governmental solution provided by one country that could implement this and get approvals in every single country. It doesn't exist. So what is going to happen, and this is probably, we're seeing this in the process of happening. It hasn't happened yet, I think, right? Because the adoption, I see it granular, like it's a few countries. But I imagine, right, what is going to happen is that this is going to get to a point where a company is going to come up with a, super good product that is going to be super easy to use and super convenient for the travelers, right? And everybody, instead of carrying this thing that you have to carry in paper, right? And you could lose it and can be stolen in your. There's so many problems with a physical passport that they're going to pitch to you that can be solved by this QR code in your phone, right? But the technology, the underlying technology of that platform is going to be a software company that is a private entity, right? Because a single government cannot do this worldwide. And this private entity is going to lobby across the globe to get this approved. And then what's going to happen is that this single entity is going to become an aggregator of identity of all the citizens on the planet. And that entity, I bet you, is already controlled by the CPC. So in reality, the CPC is going to have the power to issue passports for every single country, right? Even fake passports, right? Imagine the position in which that will put us, all of us, right? They could create identities for these agents, like, digitally. They don't even have to print the passport, right? It's a dangerous situation. The digital driver's license, right? I also seen this in many states in the US. There's a push for digitalizing the driver's license. Now it's the same, right? There's going to be a company that's going to do this, and they're going to lobby to get it approved, and in every single state. And at the end, all the driver's licenses of the US are going to be issued by the Communist Party of China. Imagine that. So now when they want to bring the agents to drive the Uber taxis with the espionage machine installed in the car, they don't even have to go to the DMV. They will issue the driver's license from China, right? That's the plan. The traffic cameras is another example, right? So until now, different counties, different states have their own traffic camera systems, right? But now there is a push that is happening for these camera systems like Flock, right? That it's a private company that has a super good system. It's solar, it doesn't require power. There's so many benefits, right? It's so convenient. Law enforcement can access it from their phone. Imagine that, right? I mean, it's an atrocity, because we know, right, by what we've seen, how weak the cell phone encryption is to the technology they have. So if an officer, even if not compromised by the network, is reviewing footage of the Flock cameras on a phone, they can intercept it, right? And even if they're not pulling the data directly from Flock, they will get it from the officers, right? So or they could inject a compromised officer, right? They could have a compromised officer in the police force with access to the Flock system and tell the officer, pull this footage and we'll get it. Like, they can get the footage without accountability, right? Without even committing a traceable crime, right? Because they can intercept it from the phone of their own agents that they have in the force. So it's also a very dangerous situation for privacy, right? Another example is air travel ticketing. I don't know if you remember this, and I remember this because I was old enough. Before 1998, each country had agencies that issued the tickets. Like, for example, in Venezuela, there was one that was called, I think, IATTA or something like that. I don't recall the initials exactly, but basically the airlines were as kind of members of this higher entity that was controlled by the government. And when you bought a ticket for a flight, the entity that issued the ticket was really the IATTA, wasn't the airline. Right? So the government had control over the issuances of the. Why? Well, it's obvious, right? Because air travel is a situation that first can be dangerous, can be, plane can be hijacked, right? And secondly, it can be used to transport dangerous or illegal things, right? So the government needs to keep, a tight leash on what is happening with the flights and who's going into these flights. And but now everything is with a QR code, right? Like if you buy a ticket on United, it's a QR code. So it's there's no government really. I mean, I guess they can subpoena that, but the digital records can be changed. So this is also something else that also changed, after 1998, right? The globalization of the issuances of the tickets, and the governments losing control over the issuance of those tickets, right? Of the air travel tickets I'm talking about. And the same with concerts. At least in the US, the issuances of those tickets for concerts was heavily regulated. Why? Well, I think, and I'm not sure about this, right? But I think it's probably because ticket scalping, right? And because these tickets have a monetary value that, it's almost like, if you think about it, right? Printing it for a high value concert or event, printing tickets is like printing money, right? In a way, right? And this is also that now with Ticketmaster, it's they issue these tickets, and it's no, the government is not. This is not as regulated as it was before 1998. So these are just examples, right? But uh, I think they show where this is going, right? It's going to a situation of full control of everything that matters to everybody in the world, regardless of your nationality, of your country of origin, of your language, of your religion. Like, the most fundamental things that mean being a human are being targeted for control. So that's the situation. So to close this section, I want to share with you my screen. Okay. I made a kind of a 1 second. Okay. Yes. I made kind of a diagram, right, to show or kind of to illustrate, right, and I apologize in advance for the bad, it's just a blank slide with figures in it, but yeah, I do that intentionally, right? Because I've learned at Google that this is a Google thing, right? Like the thing, when I show you the slide, you're gonna laugh because it looks childish, but it's a technique of communication in the sense that if you make a slide that is shiny and full of colors, and what you're really doing is distracting the audience from the things that are important, right? So I want to give you the information. I don't want to distract you and dazzle you with colors, right? So I think this is, yeah, so this is 4 slides, right? Basically summarize the conflict that I've had with this, I would call them terrorist organization, right? The Communist Party of China, for 20 years at this point. And I've described in one of the demos before, I think it was D91, what I called I'm going to start explaining what this diagram means, right? I described the same level attack, okay? And I said, every society, a societal system, there might be exceptions to this, right? But 99% of the societal systems in the modern world are hierarchical, meaning there's fewer people at the top than people at the bottom. By whatever metric you measure, whatever the metric that you choose to define prominence could change, right? It could be, you could say, well, amount of money you have, right? Or amount of political power, or amount of Twitter followers. Like, you could define any crazy metric. It doesn't matter. But any metric you choose will lead, in societal systems, will lead to a hierarchical distribution, and there are fewer individuals at the top, meaning where the metric is higher or of higher value than individuals at the bottom, right? And that's why I represent them with this triangle. And the idea is you have the real society, right, which is this, which is where everybody is, right? Yeah, and if you want to visualize it, right, at the top of the real society, you would have the presidents of every single country, right, that is not controlled by the network, right? For example, right, if the metric was political power, if the metric was amount of money, then at the top you would have Elon Musk, Travis Kalanick, Donald Trump, all those people, right? The people that have billions of dollars in net worth. And then you have the bizarro state. The bizarro state is this triangle here on red, right? It's a smaller society, that I believe is about 2% of the population of the planet. Or depends how you count it, right? I have different numbers, but let's assume that it's 2%. Okay. Um, and these are the people that are part of the network, that have been recruited by the network and that have the app installed in their phone and that are doing this, right? And this symbol is, the Bizarro state, which is headed by the CPC, the Communist Party of China. So what the CPC does and the Bizarro state basically is that they created this society, right, with these individuals, and these individuals have two main tasks. One is to spy on the others, on the ones in the real society, in this one, right? And to harass certain key people, targets, right? Targets could be targets because maybe they are political opponents of people on the Bizarro state side, or they could be targets because they could be competitors, commercial competitors of people like Elon Musk, right? That was my, or Piero Midyar, right? When I started building these startups in 2005, I was targeted immediately within weeks because I was doing something that could compete with Piero Midyar and Bob Briscoe, right? So they put me in the target category. And I was in the category, and there's also a hierarchy of targets, right? The targets, there are people that are more targeted than others. So I was in a lower category in that stage, but when I started working on health, and then by therefore attempting to compete with WebMD, I was upgraded to a higher tier of targeting, right? So that's when they bought my cars and, upgraded the wires, the box on my house to video, like, this is described in the book. And all the other things that they did, right, was because I started working on the medical vertical, which threatens the position of WebMD. And then when I captured the geo-index, which I'm going to talk about in a few slides, in 2 slides, then I was upgraded to the highest level of targeting, I believe, right? So then they started, they went nuclear, right? And that escalation is what brought them to this point, or brought us to this point, right, today. But the main idea I want to tell you with this is that the idea is that people in the Bizarro state should target either for espionage or for harassment people at the same level, right? So, for example, people at the top of the Bizarro state would target people at the top of the real society. And this makes sense for many reasons. Right? First of all, they allowed them to blend in better, right? Because imagine, right? Like, I think I put an example in the previous demo of baseball players, right? So if you have a team of 12 baseball players and you want to spy on all of them, all you have to do is to compromise one of the players, because that player is going to be in the locker room, is going to hear everything they talk. I mean, the phone, right? He's going to have the phone next to the other players while they're talking, right? And everything is going to be recorded by the CPC. And, when they go partying or where they, go out with girls or whatever, right? This agent is going to have the phone, and the phone is going to record everything and send it directly to the CPC. So you see why this works, right? Because they're injecting an agent that blends naturally because he was already part. I don't know, right? It could be that the person was already part of the team in this example, or he was promoted to be part of the team because he was an agent. Like, either way, right? But the end result is that he is an organic player in this society, right? I mean, in this society, right? Or if you think of a president, right? So if you have a president of a country that you have compromised, or that you promoted to president of that country, when that person goes to the United Nations to give a speech or to hear a speech, and he's sitting in there, he's holding that phone, and that phone is recording other presidents, right? Or when he's meeting one-on-one with a president that is not compromised, the phone might be over there. Like, I don't know the protocols. Like, maybe, I don't know, like, maybe the Secret Service takes away the phones of everybody, right? If there's going to be a meeting, I don't know, right? But you get the idea, right? So people at the same level blend better with the people in the real society. So that's why they do this, right? Now, what I believe was the strategic mistake was on what I'm displaying on this chart, right? So what they were doing in 2005 onwards, in 2005 was when I created that first startup that was a small classifieds website, right? That attempted to compete with AutoTrader, which was controlled by Bob Briscoe. So when that happened, they started targeting me, right? And you saw people at the top of that society, Briscoe, Piero Midyar, when I at some point I generalized that classifies website because I realized, well, I build infrastructure for a classified website for cars. I might as well just create categories and make this a classified website like Craigslist, right? And have all categories, not only cars, like electronics, arts, everything, right? So you see, right? It would compete with eBay. And then I had the idea, well, I already did this. I was in Canada at the time. I already did this for one city in Canada. I might as well just expand the cities and do it for all Canada. And then I had the idea, well, I did it for all Canada. I might as well expand it to other countries. And I launched it in 10 or 12 countries. Right? So it was a direct competitor to Pyramid Art. Right? So that's why in 2005, they started targeting these high level individuals, me being somebody middle class, right? I mean, I, I'm not going to say that I'm poor, but I'm not rich, right? Like I'm middle class, right? Um, and back in 2005, I was even below middle class, I would say, right? So, but this was a strategic mistake because the fact that these people are so high level, they were already billionaires, right? And it wasn't one billionaire; it was a group of billionaires, right? Targeting an individual of such low level creates this imbalance where high energy can be observed, right? And this is what ultimately it took me 20 years to get to this point, but eventually I got to this point. But it's not because I'm smarter than them, or it's because they created these high energy situations that made obvious what they were doing, and that allowed me to see the reality, right? So then what happened is that I'm just giving you the summary of the conflict, right? So even if if you don't have time, you don't have to read the books. This is basically what happened, right? So on September 24, 2024, last year, the Venezuelan intelligence, in this process of harassing me under the orders of WebMD and Bob Briscoe and Piero Midyar and Elon Musk and all those people, they leaked the database to me. They did things that gave me the database. And I was able to get a copy of the entire database and decode it. And what happened after is then the conflict changed because then what I started doing was using the data in the database to report them to the IRS so the IRS would attack them at all levels in their society, right? So this is a conflict right now where I have all the data and I'm giving all the data in because I cannot report all the it's 2% of the planet, right? If I report 2% of the planet, the IRS is going to ignore me. But I can report key people in the bizarro state structure that could cause the downfall of the entire structure, right? For example, Robert Mueller, right? Robert Mueller is such a fundamental piece of this that if he falls, many things will fall, right? So this is basically the overview of the conflict until this point. So with this, I'm going to close part one of this demo, and I'm going to move on to the technical topics, okay? I'm going to ask that you excuse me for 2 minutes. I'm just going to get a bit of water, and I'll be right back with you, okay? I'll cut this part, this 2 minutes of blank space in the video, after I edit it, okay? Just one second. Hello. Yes. So welcome back. Um, so I'm going to move to the second part of this demonstration, right? Which is really more like a training. It's going to be more like a training session. Just one second. So let me switch gears here. Let me close this. Okay. So technical observations. Okay. So this part is going to be technical observations, and I just want to mention a couple of things before I start. I want to tell you, right? When I tell you these things, I'm telling you these things as a witness, right? I these are things that I observed and I've measured. Like I've run experiments to be able to make sure that these things are the way I'm telling you. I'm not here. I'm not judging these systems or these implementations and I'm saying this because I've been working on the tech industry for many years, and I know that in this industry, people are opinionated, right? And I am opinionated myself, so it's not a critique. It's just something that seems to happen organically. Like people that have strong opinions tend to go into technical careers, into these technical careers. I don't think it's a consequence. I think it's probably a cause of people getting into the technical field. But um, so like I don't want to turn this into a debate of technical opinions. Um, and I don't want to discount anybody's opinion, right? At the same time, so what I want to say is two things. One, what I'm telling you is based on years of witnessing this, right? And it's possible that another person in the world has had the same opportunities of observing all these things for years than me. It's possible, right? But I think the fact that I've been exposed to this on the receiving end for years gave me an advantageous position of observation or point of view, right? And that's what I'm offering you. My experience observing this, not my opinion. And the second thing I want to say is that over the last, I don't know, 20 years, 25 years, right? 20 years, the network gave me employment opportunities. They employed me in places where I was exposed to a lot of technology. And is that learning that they gave me, those learning opportunities, a big part of what allowed me to see all this, right? So I think it's I guess what I'm trying to say is I beg you to give me the benefit of the doubt on the technical things that I'm going to say, because ultimately the solution will require sending this information to people that could make a change. Like I don't have the power to change the things on the internet. Like I have no control over over anything, right? I cannot change the W3C standards. I cannot change, how the protocols work. So you need to send this information to somebody that can make those changes, right? That can affect that change. Uh, so it will require a chain of people giving me the benefit of, or giving this information the benefit of the doubt. And if anybody in that change discounts the information, thinking yeah, this is not technically right, then this is not going to get what it needs to get. Yeah? I'm hoping for the best. Anyhow, so the first thing, right? I ran. I also need to say I'm going to go deep, and I'm going to talk about things that maybe I may say words that maybe you haven't heard before, right? If that's the case, try to seek advice from somebody from Google, right, that works in these things, that can explain, because I cannot go into details into every single concept because this would take weeks, right? So I'm going to give you a very concentrated version, but it may contain words that maybe a viewer or some viewers may not understand fully, right? So you may need to seek advice from somebody from Google, right, or from, I would say probably Google, right? So the first thing, right? over the last few months, right, I've been buying computers, like small computers, desktop computers and laptop computers, and that I've been using, right? And the first thing I do is to install in these computers Chrome OS, or that I was doing, right? And the reason why I installed Chrome OS is because I thought, well, Google. I mean, as I mentioned, right? Like I used to work for Google, and I have a deep respect for technical people that work at Google, and intuitively I trust things that come from Google, right? But that is my bias. That it's a bias really that I have. I should have not trusted that. But anyhow, I went and bought computers and installed Chrome OS, fresh installations, right? So I downloaded the latest Chrome OS and installed it in these computers. I ran a series of experiments, and I was able to see that they had a keylogger logging every keystroke that I type. And this is not me being paranoid. I can tell you, they have a keylogger on the Chrome OS that can see every keystroke that I type. Now, on the Chrome OS computers, right? After I installed the OS, when I bought the computer physically from a store. So I went to the store and I bought this computer. So this is not a hardware keylogger, right? Because I bought the computers, they were not shipped to me. I went and I picked a computer pseudo randomly. Nobody could have foreseen that I was going to pick that computer that day, right? And I bought the computers. I did this experiment as well in different places. I bought one of them at Walmart, two of them at Walmart, one at Best Buy, one in Micro Center, two in Micro Center. All of them have the same behavior, right? So this is something that is done at the operating system. Now, I don't know. This is something that I don't know yet. If the operating system is doing this for everybody that has Chrome OS installed, I don't know that, right? Or if it's an experiment. When I say experiment, Google, they have an experimentation platform. Oh, this is another disclaimer I'm going to say. I'm going to say some things, right, about systems that are used in companies like Google, but I'm not going to disclose anything proprietary about the technology, how the thing works. I may say, they have a system that does this, right? But that is not, I'm not disclosing the internals of the system or how it functions, or like, I'm just saying with the general principle of what is that thing does, right? And the things that I'm going to say, I already checked, and there are forums online that mention this system. Right? So this is information that is already public, right? And at some level. Some technical forums in the internet, these systems are already mentioned. I'm not mentioning anything that is secret, right? So at Google, they have this experimentation platform, which allows to expose users, specific users, not by name. They cannot target the user by name, but they can target by criteria. They can say, users in, I don't know, the US that are between 30 and 40 years old, and that, I don't know, have interest in cars. Like, they can set criteria like that, right? And that results in a group of users that get put into the experiment. And the experiment, what it does, it exposes these users to a modified version of the software, right? It could be a modified version of the ranking algorithm in Google search. It could be a modified version of the UI in Gmail, right? It could be many different things. And then they measure behavioral metrics, right? Like how much time you spent on the page, how many attempts you had to, how many queries you have to type to get to the result you wanted, things like that. So one way that I can see how this could have been done to target my keystrokes specifically was to design an experiment so specific that only I would follow in the experiment, right? And I'm talking about a Chrome experiment, right? A Chrome OS experiment. Experiment with conditions that are so restrictive and specific that only I follow in the experiment, right? And then in that experiment, there is a keylogger, right? That logs my keystrokes. It's a possibility, right? I cannot prove that this is what they did yet, but So of course, I had to discontinue the use of Chrome OS for this reason, right? So now I have a computer, which is this one that I'm using to give these demos, because the demos are already going to be public, right? Like the intention of this computer is to create information or videos or recordings of things that I'm going to make public anyways, right? So if they see the keystrokes, I don't care, right? but it's the only computer where I can use Chrome OS, because otherwise they see my keystrokes and they know if I'm going to buy something, if I'm going to go somewhere, if I'm going to anything. Even if I make a note, it doesn't have to be, the computer doesn't have to be connected to the internet. I also determine that. Like, I can disconnect the computer from the internet, type something in a program that has nothing to do with the internet, like a notepad, right? And then I connect it to the internet and they see what I typed. So the thing is able to remember the keystrokes I typed when the computer was offline. And when it becomes online, it sends the keystrokes. So that's Chrome OS, right? Now, I have to say here, Chrome OS obviously is an aggregator, right? Like, in general, all the OSs, the operative systems that are not open source, are aggregators. Right? That's why you see this heavy concentration of operative systems, commercial operative systems, right? In fact, let's do this right here, right? Like, if you Google this, what is the market split in commercial operative systems in the US? Let's put it for computers. So there you say, right? So Windows has almost 60% of the market, Mac OS 30%, right? So just those two is 90%. That means that if you're able to compromise these two, you can spy on 90% of the US. Like, so you see the power of the aggregator here, right? So this is why they go for the aggregators. And next is Chrome OS, right? And this number is so low, 3.6%, that it makes me think that probably it's not being used generally as a keylogger, right, or as a tool of espionage, but it's an experiment that they injected into my version of Chrome OS, or my experience of Chrome OS, to lock my keys, right, my keystrokes. But I don't know, right? Ultimately, authorities needs to investigate this, right? So that's Chrome OS. Now, I also, on this point of aggregators and experiments, right, I want to say there was a demo in which I said that they had promoted Vanadium, which is a browser that I use in one of my mobile phones that runs a customized version of Android. Because I'm running experiments to understand how is that they do this, right, in the operative systems. I know it's in the operative systems, right? Like the deepest place of compromise, that, not the deepest, but like the more obvious, because they also can compromise hardware, right? They can put keyloggers in memory, and they have done, in memory modules, they have done this to me. But anyhow, the obvious thing is to use as aggregators are the operative systems, right? So in one of the demos before, I said that they had promoted Vanadium to tier 1 at Google. And this is one of the words that you have to consult somebody at Google. But I want to give an errata on that. That is not the case. I realized, running experiments myself against them, that that's not how they did. They did do what I said that they did, right? They promoted my version of Vanadium to tier 1 to make it more vulnerable. But it wasn't done via the browser tiers file at Google. It was done via the Mendel experiment platform at Google. And again, the way it works, they set up some experiment. I don't know exactly the ID of the experiment because it's encrypted, but I can see that they put me in an experiment that forced my browser to be tier 1, and they also injected a customized login into the experiment. So when I go to any Google property, I get a super heavy level of login, and I can see, and I'm telling you this because I worked as an engineer at Google, and I made changes with these hands on the login system. I know how it works. I know how to see the log events, right? So I see the log events that are fired when I use the Google properties, and I see that this thing has heavily customized login, probably injected for me, right? And it's logging things that are not, obviously are not the custom things that you would log at Google, right? For everybody. So this is a vector of attack. And they do this thing for two reasons, right? One, to see what is that I'm seeing online, right? To see what because they're desperate to understand what is that I'm looking at, right? Because of this conflict that we are in, the slide that I mentioned before, right? They see the risk that the IRS could act on this information that I'm providing to them and, seize properties from all these people, key people in the network, right? Which puts the network itself at risk and the CPC by extension, right? Um, so they put me in that heavy experiment with heavy logging. Um, and also promoted the browser to tier 1, which makes it more vulnerable. And I'm going to explain in a few minutes why, right? And I'm going to show you why. Um, the other thing I want to mention, I'm here on the internet now, right? By looking at, oh, you cannot see that? Oh, interesting. Yeah, so I'm basically talking about this. The other thing I want to say is that at Google, they had this, it's an infrastructure that allows, it's a very select group of engineers. Like, this is not something that, every engineer at Google can see, right? And the vetting to get permissions to use the system is very high, right? And when I was at Google, I had access to the system. So I can tell you, because I was exposed to that, and I know how it works, and I know the events that get logged. So when I said that, so let me tell you what the system does, right? The system allows for engineers that are debugging things, and this is needed for Google engineers to be able to improve the quality of the results, right? So they're able to basically replay the session, is what we call it, right? So they can basically imagine, like, it's not like they're recording the screen, but they're recording the events that you do on the search page, for example, right? And then they can replay the events. It's basically like like a browser, and they can see in that browser, what is that the user did, like, enter this query and then clicked on result number 3, which had this title, and that take him to that page, and then he came back, and then he went to Google Maps, and this is cross property, meaning this can track and replay sessions in multiple properties. Like, doesn't have to be all search. It could be search, Google Maps, Google Photos, and you can see the journey, right, of the user. So in the special experiment that they put me, I can see that the experiment and the login, that the custom login that they put in that experiment is designed to maximize the stitching capabilities of the user session system. I can see that, like, based on my own experience as an engineer at Google. So this tells me that there is somebody at Google. I don't think this is a corporate thing, right? I think they have somebody at Google, an engineer, but probably somebody high level, right, that has this level of access to, either do it himself or instruct somebody or a small group of engineers to do this, right? They designed this experiment that maximizes the tracking capabilities of my user journey across all the Google properties, right? And I'm telling you this based on inspecting and debugging the login events that I see in this heavy experiment that they put me on, right? So I don't know. It's just a tip, right? A lead. Yes. So with that, I'm going to talk about the browsers, right? So I'm here in this point. The web browsers, also function as aggregators, and we can also debug this right here, right? Like, oh, I didn't show you that properly. I see. Okay, let me stop sharing, and let me reshare. Yes. So before I was talking about the market share of the OS, right? Of the different OSs, operative systems. Sorry, the sharing doesn't want to work. Let me do something. Let me close this. Close this as well. I'm going to open a new window. I'm going to share that window. Okay. Okay, yes. So when I was talking about the OS split, this is what I was sharing, but I realized that the sharing wasn't working. So I'm sharing it now. So you can see Windows has almost 60%, Mac OS 30%, Chrome OS 3%, Linux 3%, right? Now, and you can see there that basically Windows and Mac OS are aggregators. Right? They can be used as aggregators in the context that I was describing. Uh, and if you do the same for internet browsers, right? You see the same behavior, right? So Chrome has 60% of the market. Edge, which is Microsoft, so the browser from Microsoft and the browser from Google, right? Combined, they have 75% of the market. So if weaken these two browsers to make the interception technique performed by the CPC possible, the CPC would basically be able to spy on 75% of the US population, right? In the power of that. That's why they go for the aggregators. But again, if you, let me go back to the calendar invite. So we're talking about the browsers, right? So yeah, so the browsers have been weakened, right? Especially Google Chrome. And I've described in another demo why exactly, but Chrome does a series of requests to things related like Sidekick, like the search suggestions, that there are requests in there that make the cryptanalysis attack trivial, because the response, the weakest ones are the ones where the response is empty. But I'm saying that just to give an example. So now I'm going to start debugging things to show you, right? So what I'm going to do, let me see if I do this. No. Let me stop presenting and let me present again. Mm. Okay. Okay. So in Chrome, if you right click, well, you cannot see the pane, but if you right click on a blank area of the page, there is an option that says inspect. And then if you click on that, it will open this debug console, okay? There's different ways to view it. I think this is probably the best, right, for this. So in this console, there is a tab that says network, which is this one. And in this tab, you can see all the requests that happen, right, when the browser is operating, right? So here, what I'm going to do, I'm going to add a column. You can control the columns by right-clicking. Size is already in there, okay? So the size is this, right? Okay. So look at this. When I do things on the page, right? So for example, I'm gonna search for I don't know, anything, like Amazon. So all these are the requests that your browser is doing behind, like under the hood, right? To be able to render this page. So let me show you, right? So if I scroll down or do some action, right? It's basically logging on and eventually it would send. Right. So this one, the gen, right? So you see, what's interesting about this request is, see the size. It's a 0 kilobytes, right? So it's a request that it has an empty payload. The body of the request, and I'm here. I'm talking about the HTTP protocol, okay? And this is very technical, and I'm going to use a lot of jargon, right? That to understand it, you need to talk to somebody that knows about the W3C standards. But I'm going to assume, right, that you either have the knowledge of those words or the jargon, right, or that you have access to somebody that does, right? Because otherwise, it would take too long to do this session. So the problem here is that the size is 0 kilobytes. That means that the body is empty, right? And you can see that by inspecting the request and then clicking on response. You can see that the response was empty. So the reason why this is dangerous or makes cryptanalysis easy, trivial, is because, well, if in my case, right, the Chinese, the CPC has people that is intercepting this internet connection at this very moment, right? So when they see the stream of bytes that is encrypted, right? That's what they can see because they have the internet connection tap from the house next door, the 2218 Britton Ridge Drive, right? That's where my internet aggregator for this wire connection is. It's an Xfinity connection. So they have it tapped there, right? So they see the GN204 request coming in. I mean, what they see really is the byte stream, right? Like, so the encrypted bytes. But they know that some of these requests will have an empty body. So because the body is empty, it's trivial to find an encryption key that could decrypt parts of that encrypted stream of bytes that they see to an empty body, right? When they find that key, when they can make that match, they have found a key. And then they can decrypt anything that comes through this session, right? Through this, they can see the searches, they can see the queries, they can see everything, right? Because they found a key using this trivial cryptanalysis attack that can decrypt anything that goes through this channel. So this is an example, right? Now, Chrome, the Google Chrome browser, because it's deeply integrated with Google services like Sidekick, Query Suggest, and things like that, it uses this GN204 facility a lot, right? So it makes it so, and this browser does this request even if you're not using it, right? Like, you can have this tab open in the background, and you could be writing, something. You can be designing something in your computer that has nothing to do with the internet. You may not be using the internet, but because the tab is open, it will issue this GN204. So you see, like, it just generated this bunch of things, right? And I didn't touch the page, right? So it's a continuously running process that it's always communicating with the internet, and in the process, Chrome is sending a lot of information and a lot of requests that are empty, that are trivial to find, that make it trivial to find a decryption key. So the thing I had to do was to discontinue the use of Chrome, right? Obviously, because but let me tell you, I tried to quarantine it. I spent a lot of engineering time trying to contain the problem, right? So I could still use Chrome. And for me, it was impossible. Right? I got to the conclusion that the thing is so compromised, it's so weak, that it's not possible for me to build a cage around the Chrome browser to make it not weak. Right? I had to discontinue it. Again, that's just my experience, right? But I have to tell you that I put a lot of effort and trying to still use it, right? Because I like it. I like Chrome. But I was not able to I had to choose between making it so easy for them and using Chrome, right? Using a product that I like. And choose to make it difficult for them, right? So I'm not using Chrome anymore. So that's Google Chrome. Let's go back to to the agenda. So we talk about Chrome. Right. So now let's talk about something more interesting, right? So now we're going to talk about internet protocols, right? And this is a bit deeper in the layers, right? So if you, I don't know if you will be familiar with this, but there is a model that explains, I think. Let me see if I can find you a good representation. I don't like that one that is shown. Yeah, I would say this. Right? Right. So this is the OSI model, right? So, and it's a representation of how the networking communications, including the internet, work. From a physical layer, which is at the bottom, to the application layer, which is at the top, is the layer 7. Application being, like, for example, if you're using uh, Google Chrome. Google Chrome would be in the application layer, right? It would be the highest level in the stack that makes the communication possible. And layer one, would be the physical connection, the cable connection between two networking devices, right? Or the air, if it's a point-to-point communication over the air. Right? So what I'm going to talk about is the transport protocol, like layer 4, between layer 3 and layer 4, but more on the layer 4, right? So I'm going to talk about protocols like TCP/IP. So when you do a request to a website, right? And let's go back to our so debugging here, right? So when you do a request, right? So say that I'm going to do this again, and I'm going to do this. Right, so I'm requesting the page. So this request, right? I'm requesting the page for Amazon.com. Okay. So this is an HTTP request. It's basically a request from your computer going to a web server using the HTTP protocol. And there's different versions of the HTTP protocol. But before we talk about the HTTP protocol, below that, the HTTP protocol functions on top of what we call TCP/IP, which is a communication protocol on which many of the services of the internet on the internet work. TCP/IP, and I don't want to go too deep into the definition and how it works, but one of the interesting properties, so it's a protocol that governs how two networking devices send information among them, or from or to them, right? And it has an interesting property. There's different protocols, right? There's FTP, there's SMP, there's HTTP, there is UDP, there's different, right? And different protocols are used for different things. For example, SMTP is used for email, right? HTTP is used for websites. FTP is used for file transfer. And sorry, I'm talking about the other protocols. So TCP/IP, for example, I want to talk about TCP/IP. So TCP/IP is more on the transport, right? And it talks about how computers send packages, right? So if you have a large website like this page, right? You cannot send. So this website, right? This page. Let's talk about a specific, right? So this page, the weight is 322 kilobytes, and you can see this here, right? And it took almost 500 milliseconds for the request to go to Google and come back. So almost half a second. So this is a large payload. This cannot be sent in one package, right? So there is a size that is allowed in all these networking systems. Like, for example, and this is set in this case, by the internet provider. The internet provider, Xfinity, has configured the routers to allow a maximum package window, right, or size, or payload. And then the entire page has to be split in multiple packages. So the entire size of the page can vary, right? And what will vary is the number of packages that need to be transferred from one computer to another to send the entire document. So in the case of TCP/IP, what happens is that one of the most important properties that it has is that it has the capabilities for acknowledgement. And this is embedded into the protocol itself. So when a computer sends one package, I'm not talking about the web page, I'm talking about a package, and a package could be part of the request. Like, so my computer saying, I want the page for google.com/search Q equals Amazon, right? So that information is encoded in packages. And that's part of the request that goes to Google. So those packages, while they travel from my computer to Google, when they get to Google, the Google server will send an acknowledgement to my computer, right? And this is a fundamental part of the TCP/IP protocol. What I'm saying is, in every package exchange, there is always an acknowledgement that goes back to the sender of the package. And this creates a fundamental weakness that the CPC exploits. Why? Because, and I mentioned this in a previous demo, again, from observation, I'm not a communications expert, right? But from observation, I can tell you that in every communication system, it seems to me like the downlink is always the weakest channel, It's the channel that it's easier to intercept for multiple reasons: physical, geometrical, logistical. There's many reasons behind this observation. Okay, I don't want to get into the details why, but please believe me that in every communication system that I've seen that they intercept, the downlink is always the weakest. So because of this, the TCP/IP creates an immediate weakness, because every package that gets sent by my computer, when received, is going to come back with an acknowledgement. I mean, not the same package, but the acknowledgement is going to come back. And because the downlink is weak, the CPC, using the house of the combination of Joel Gray, John Michael, and the realtor that now gave his house to the Chinese agents, because they're next to me, they're going to intercept the downlink, right? If I use air, if I use the Comcast cable, if I use the satellite internet, they're going to be able to see the downlink. And in the downlink, they're going to get the acknowledgement, right? And in the acknowledgement, they're going to get information that could allow them to decrypt the entire channel, right? That's the weakness. So every package sent produces an acknowledgement that comes back. And by listening to that acknowledgement, they can see the MAC address, they can see important information that allows them to anchor their cryptanalysis techniques or tools to then find a decryption key and decrypt everything, right? So the TCP/IP protocol, which is the foundational basis of HTTP 1, so 1.1 and 1.2, sorry, 1 and 2, is weak, right? And that makes those two protocols weak. So those two versions of the HTTP protocol, they're weak because they imply TCP/IP, which implies that acknowledgement for every single package, which implies endless opportunities for the CPC, the Communist Party of China, to intercept your network traffic. So the solution to this is really simple. Use HTTP 3. Because HTTP 3 is based on UDP. UDP is a different protocol. It was, I don't know if it was created, but it's mostly used until now in things like gaming, where what's important is speed more than reliability. The good thing about TCP/IP is that because you get the acknowledgement, if the acknowledgement is not received, the system automatically retransmits the package. So it's very reliable, right? But at the cost of always having to expect this acknowledgement, which makes the whole security of the system weak, because the Communist Party of China is always looking to intercept these acknowledgements, right? UDP, on the other hand, is a protocol that doesn't expect an acknowledgement. That's why it's faster, because it just sends things hoping for the best. If it doesn't get received, well, bad luck. So that's why it's using gaming, right? Because gaming, you care about the latency. You want a fast gaming experience, and you don't care. I mean, if some packages get lost, what will happen is that your character will freeze, right? And you get shot in Call of Duty, right? That's the worst thing that can happen. But all things considered, it's better to gain the speed overall and have those small moments of lag where you could get shot by an opponent, but it's the price that you have to pay for being able to play at a fast pace 99% of the time. So UDP doesn't expect an acknowledgement, and that makes that protocol stronger, because there's nothing that will come back that the CPC, the Communist Party of China, could intercept. Now, HTTP 3, which is a newer protocol, is designed to work exclusively on UDP. So no TCP/IP. That destroys the possibility of them exploiting that acknowledgement. And this leads me to another observation. So I run a lot of experiments with this, right? So what I did, I configured my system, this experiment, right, that I run, in which I would block the ports for HTTPS, or 443, for TCP/IP, but not for UDP, effectively forcing the browser to only accept HTTP 3, right? So I was creating a situation in which HTTP 1 and 2 were impossible to accomplish because the port is blocked with that protocol, with TCP/IP, but not with UDP. So I observed something very interesting here. What I observed in this experiment was, the browser starts communicating with, I'm going to talk about Google specifically, right? So it opens the connection to Google and starts communicating, negotiates, and obviously I'm blocking the TCP/IP port, the TCP/IP protocol, right? So the browser goes to HTTP 3 and starts talking UDP, right? And I can browse, like I can browse the internet. I can browse Google, right? I can use it. The experience is functional. But the interesting thing is that there are some requests that happen that are forced to HTTP 1 and 2, despite the protocol being blocked. The browser knows it's blocked because all the requests are failing on that protocol, and the browser knows that the Google server is capable of handling HTTP3 because the experience is functional, right? So why are these specific requests being forced to a lower version of the protocol on the same server, on the same path as requests that are working? This hints to me that there's intention. So the reason why those specific requests are being downgraded intentionally, despite this situation that I'm forcing that they should not be downgraded, is because these are requests that are being exploited for this. Because, to exploit the fact that HTTP 1 and 2 are weaker, right? Because of the acknowledgement coming back, and also because the encryption is weaker than HTTP 3. So this tells me, right, there is somebody at Google, probably in Google Chrome and Google Search, right? There has to be at least 2 agents, one in each team, that are making this situation possible. And this situation is intentional. This is not a bug, right? This is a feature. It's a feature designed for the CPC to be able to do what they do. So it's something that needs to be, I would look into that, right? If I was tasked with that. So yes, let's see where we are. Yes, so we talked about the low-level weakness, right? So this is the protocol attack, right? So the TCP/IP attack, and the quick fix is to force UDP. Of course, to force HTTP3, which means forcing UDP. But of course, this is a workaround, right? This is not the fix, really. This is just a workaround that I'm doing to make it difficult for them. But the real solution is that somebody with the authority to make the W3C change this is to deprecate HTTP 1 and 2, right? Because otherwise they will keep doing this, right? I mean, the CPC. And force everybody to be quickly on HTTP 3, which implies UDP, right? Okay, so now I'm going to, when we saw the OSI model, right? So what I was describing until this point is on this part, right? Now, probably I should, I was going to talk about level 7, but I think I'm going to talk about, session, right here. So I'm going to move this item up. Yes. So I'm going to move, I have it just one below, but I'm going to move it here. So this is about the cookie, okay? So, the cookies, let me show you what it looks like. Right? So if I go to this website, right, to this request that I specifically show you. So this is a request for the page of this Google search that I did for Amazon, right? So if you look at the headers, there is a header in here in the response, or yes, this one that says set cookie, right? So this string is the cookie. So you see this string that says SIDC equals, and then it has this bunch of characters. So these characters after the equals, that's my cookie. So that is a string that is a unique identifier for Google. So this string is created by Google when I make my first request to Google, and it gets persisted across multiple sessions. So if I close this browser and open it again tomorrow, this cookie will persist unless I delete the cookies, right? But this creates a weakness. because this is a fixed string that is small. You see how many characters they are, right? So if, because the Chinese, the CPC is capturing my traffic right now, right? They know that this is the cookie that this browser is using. So in all requests that I do to Google, they know that this string is going to be present in this header. And not only that, the header on itself, like this string that says set cookie, is also a fixed string, right? So they already know two strings that are going to be present in the payload of the response. And that these two things are already two very strong anchors that they can use to do cryptanalysis attacks and find the decryption keys. And then once they find them, they can decrypt everything on the channel. So what I'm saying is the fact that this small string, these two small strings really, the header name and the header value for the cookie, are going to be present in the response or in my request. Like if I make a new request to Google, then this same string is going to be present in the cookie header, not the set cookie, the one going out. So they can also, with that, decrypt what I'm sending to Google, right? So this is a very dangerous string. This string is what's used by Google and other companies to put users in experimentation buckets, right? The one I described before, right? So the fix for that Mendel experiment that they are putting me on, I have a 4-step process that I do to basically make this impossible for them, right? So what I do is I open, so say that I'm on a phone, right? I open, and this part is me showing you how you can circumvent what they do, right? So if you want to do one request to Google search, but this only works with one request, right? The first request you do. You have to do this on every request if you really want to have privacy about what you're searching for, right? Like, don't trust on that thing that says, this is a private browser. Like if you open the browser, it says open a private window. That is not really private, because if you make multiple requests within that session, all those requests are going to have the same cookie. And because they might be intercepting your traffic from the houses next door, after you do the first request, they will be able to see everything after that, right? Because they're going to find the cookie, and then they're going to use that cookie to decrypt everything, right? So, so the technique is the following, right? So I start with an empty browser, right? I open an incognito window to make sure that nothing from my previous session is mixed with this, right? I delete all the cookies for all the time. Then I do the search I want to do, right? In the incognito window after having deleted the cookies. After I do that search, I don't click on anything, because if you click on anything, I mean, you can only see the results, right? But you cannot click, really. Because if you click, they may have other ways to track you. In fact, they're going to track you by the click. But then what I do is that I close the incognito window. If I need to do another search, I close the incognito window, delete the cookies, open a new incognito window, and do another search. This way, I get a new cookie that they haven't seen before, and therefore, they don't have the key to decrypt the page, right? They don't have the anchor to do the cryptanalysis on this byte stream. So if you do this consistently, they won't be able to find the key. So I'm just giving you a trick how you can circumvent this, right? But of course, this is not a long-term solution for the world. What we need to do is to get rid of these cookies, right? And this is, again, this is something that falls on the W3C standards that needs to be changed at that level. So historically, this cookie makes sense because in 1998, when the PayPal Mafia got started, the technologies we had, the world, right? The connections of the internet, I mean, people probably don't remember this right now, but the connections were dial-up, right? You would, I don't know if you would remember that you would have this device next to the computer that would connect to the phone line. I would make these noises, and would connect to the internet, right? At 55 kilobytes per second. So at those low speeds, the amount of data you could transfer was small, and that justified this concept of a fixed cookie that would never change, that would be small, right? But that was the world in 1998. With the speeds that we have today, computing power, internet speeds, these constraints are not needed anymore. We could have the equivalent to a cookie, but that is not really a fixed string, it's a certificate that changes on every request, right? That's the solution, to make this be a certificate that gets randomized on every request, that still checks out with something that the server side has, but it's different on every request and it's longer, right? It's multiple kilobytes long. Because with the internet speeds we have today, we don't have this constraint that this thing has to be, I don't know, 256 characters. I don't know what's there's a limit on the W3C standard of how long the payload of a header can be. So that needs to be changed, right? Also, the header names, right? The fact that these headers names are there, server, set cookie, report to, all these things are fixed. And all these things are anchors that are trivial, that make cryptanalysis trivial and are unnecessary, right? And there's solution. I'm not going to get into the implementation of this, but if you're interested in seeing a possible implementation that doesn't require sending these fixed strings on every request or receiving them, look at how Google implemented the protocol buffer protocol, right? It's a protocol that doesn't require sending the name of the columns on every request, right? Look at that, and that could be copied into the HTTP protocol, right? By the W3C, and that will solve the problem of having all these fixed strings in the header names. But you see, the idea is, the name of the game is to eliminate anything that might be constant or fixed among two different requests. That should be the goal. Nothing should be repeated if it doesn't need to be repeated. We need to avoid situations in which multiple session requests contain the same information, because that is just asking for the CPC to do what they do. Right? All right. Yes. So I was talking about your cookie, how to avoid the problem for now as a workaround, and how to ultimately fix it. Right? Yes. So the level 7 attack. So this is going up in the model, right? So now we're talking about level 7, right? So here, application. So application would be things like Chrome or even Gmail within if you open the Gmail website on Chrome, right? So what I want to show you is that if you go to Gmail, right? Okay, so I open Gmail, right? I'm gonna clear the history, and you see I'm not doing anything, right? But you see, you're gonna see how this thing keeps doing requests and it's doing things on the background, and this is always happening, right? It doesn't matter what it happens on an interval to keep checking for emails, and even if you don't do anything, this is going to be issuing this request, and many of these requests will be empty requests like this Gen 204 that we talked about before. You can see it here, right? That it has 0 kilobytes, right? You can see it here. Right? So just by having this window open, your computer is creating all this network activity on predictable intervals that have all these weaknesses that I talked about, including there's some requests in here like the images, right? Like these sprite GIF images that are forced to go onto these lower versions of the protocol, HTTP 1 and 2. And the images are like the sprite images using Google and Gmail are particularly dangerous because they're fixed content. Like the network, the CPC knows what is in those sprites every week, right? Even if Google changes the content of the images, the CPC knows what is the new content, right? So all they have to do is reconfigure their system, and they can use this to attack everybody, right? That downloads these images on these weaker versions of the protocol. So, but beyond that, what I want to show you is that even if you're not using the Gmail, even if you have it in another tab that you're not seeing, the thing is sending this request on predictable intervals of time. And these requests have been intentionally weak to what the CPC does. So it's a dangerous situation, right? And I don't know if you do this, but for example, me, I have the tendency of having 50 tabs open, right? And I could have the Gmail open in 5 different tabs. And so this creates a weakness. Because obviously, all these tabs are communicating and creating these network events that have all these weaknesses that I've already described combined, right? So it's asking for it. Like, they have endless opportunities to do cryptanalysis with what they're seeing on the encrypted byte stream. So I guess this is more of a what this calls for is more for a paradigm shift, right? Um, and like this is probably a more philosophical and longer conversation, and I think yeah, it's probably something. Um, how do I say this? Because it would be talking about a behavioral change on a large group of individuals, right? I think that's very hard to accomplish. Um, but I can only tell you. I cannot tell people what to do. I can only tell you what I've done, right? What I've learned is that this behavior, of this way of thinking, of being always connected, like having a device in your pocket that is always connected to the internet, that is pushing things to you, this is what makes this possible, right? Is this dependency on, it's not even being connected, is I think that in reality what is dangerous here is the push model, right? Where the internet pushes things to you. Think about your Instagram notifications, right? You could be having dinner and your phone beeps and tells you, hey, something happened, right? This is a push event to you. This is the internet pushing things to you, but this requires the device to be online all the time. And because the device is online all the time, and you have all these applications installed in the device that have all these weekend requests, you could have any number of applications installed in the this is not only Gmail and the Chrome browser. You could have, anything in your phone, and the applications could be weakened in the same with the same technique, right? The same TTP. So your phone is always connected, always receiving, and always sending events and acknowledgments, right? And that's make the device weak, right? The CPC can intercept anything on any direction, right? Either the message itself or the acknowledgement on either direction, and use that to decrypt your entire channel of communication and see your emails, your calendar, your voice messages, everything, right? So from a privacy point of view, this mentality or this way of operating within society, of having this push model where the internet pushes things to your phone, creates these systemic weaknesses, right? And there's no way to avoid that if we don't adapt, right? So what I found is that I can adapt my behavior, and now, I mean, I carry a phone, but the phone is always off, right? I only put it in transmit mode, not off. I put it on airplane mode, right? Um, well, and there's some operative systems, I have to tell you this, right, where the airplane mode is not really airplane. So they weakened the airplane mode, and the phone is still able to receive and send things, even if you think it's in airplane mode, right? But yeah, I'm not going to get into that in this session, right? Assuming that the airplane mode really works, uh, what I've done, right? Because in this one I configured in a way and I did things that I'm sure that it works, right? The airplane mode in my phone. But this is not true for every phone. There are phones that you click on airplane mode and you think it's in airplane mode, but the thing still transmits and receives. And I've run experiments with this. Like, this is not observational, right? This is I've done experiments with this, and the CPC agents that I have next to my house. So, but yeah. So back to the conversation: is this way of thinking of being always connected and being always open to a push from the internet? That thing is the situation that creates systemic weaknesses on your device, and it's impossible to mitigate them, right? As long as you're operating in this mode. So what I'm doing myself is I change my mode of operation. My phone never receives unless I need to use it, right? If I need to send a message, I take it out of airplane mode, I send the message, and I put it back on airplane mode, right? So that way, even if they catch that message, they're only going to catch that message. They're not going to use that information to do cryptanalysis on anything that I do later, right? They would have to be following me, which they do, right? Because I'm now in the highest level of targeting of the CPC. But if I was, at a lower level of targeting, they would not be following me around all day, right? But they can be following around all day everybody, right? So that's why it works. Because if you're, as long as you're not in the highest level in the hierarchy of targets, you can go to some place where they will not be next to you listening, right? To the radio frequency, I mean, of your phone. But yeah, so this is more of a behavioral shift that maybe needs to happen. I don't know, right? It also depends on how much you value privacy, right? Because some and this is interesting, right? In this process, I've talked to people that are agents of the network, right? And like at some point, like we had these conversations, and I know they're agents, right? And they know I know. And we had, I mean, obviously they don't tell me, right? They don't tell me, yes, I am, right? But they deny it, but, they know, I know they are, right? So we had these conversations at some point, right? And a couple of them actually told me, the two of them gave me the same argument. And this was interesting, right? We were talking about privacy, right? And these things. And the two people in different times, without coordination among them, gave me the same answer. So this makes me think that maybe this is what the network believes, right? Like they tell the agencies, right? But anyhow, the conversation was about privacy, and the two people in different times, in different situations, without coordination, told me that they believe that even if I succeed at exposing the network, the world will not care, because people are already used to privacy intrusion. Like that, they told me that, right? They told me, I don't know, I could try to quote it, like this was a long time ago, right? But it would be something like, I don't think that if you expose this, anything is going to change, because people are already used to their privacy being invaded for many years. So it doesn't matter what you do, right? I mean, what I do in terms of trying to expose all this, right? And I don't know, right? I imagine there might be a segment of the population that, like, for example, me, right? I've learned to live with this. I don't care. Like, really, I don't, if the Chinese next doors, there's certain communications that I do with informers and things like that I have to protect them, obviously, right? But, if they see what I'm searching on Google, or I don't care about that, right? Because I'm not, they can, I mean, I learned to live with this, right? That doesn't mean that I'm going to put the informants at risk, right? Also, I don't think it's entirely an individual decision. Why? Well, let me give you an example. You might individually think that you don't care if the CPC is spying on you, and that's okay. But if you work at the Pentagon, I don't think the Pentagon will allow the CPC to use your phone inside of the Pentagon to listen to what everybody is saying, right? So what I'm saying is, you as an individual might be okay with the CPC listening to everything and seeing everything you do, but that doesn't mean that the Pentagon is going to be okay with it, right? So there is a difference between individual acceptance of invasion of privacy versus institutional acceptance of invasion of privacy. So my answer to these two people that told me that was, well, yes, but I don't think if I expose this, that the government, the FBI, the Pentagon, the IRS, right, is going to allow their employees to bring an iPhone inside of the office, right? I imagine, right? I mean, if you know what the CPC is doing and that they're using the iPhones to do this, you are going to ban the iPhones. I think that's the logical move. I mean, that's what I did, right? I banned the iPhones from my home a year ago, right? Because I can see that the iPhones put me at risk. If the CPC knows what I'm eating, what food I need to buy the next time I go to the store, that puts me at risk, obviously, right? Because again, these are people that harvest organs from living human beings, right? They have no problem in tampering with my food. Because they are a terrorist organization, right? So I can't allow one of their iPhones inside of my home. It's obvious, right? So I don't know. I guess we'll wait and see what happens, right? What people do when they know what the CPC is doing with the iPhones. It's one of those things where we have to wait and see. But going back to the level 7 attack, the technique is having these applications like Chrome or Gmail or Gmail inside of Chrome that are always communicating using this intentionally weakened request, even if you're not using the application, right? So, there's two things that you need to do. One is, if you are one of the people that have 50 tabs open and forget about them for weeks, I'm in that group, right? You have to change that, and you have to, develop the habit of always having only one tab open, right? So you can have control over what is that your computer is doing. But I think there has to be a fix at a lower level, at the OS level, right? It's possible to create something in the OS that limits what the application can do if it's not in focus, right? If you don't have the tab selected, the network should be shut off, right? I think that would kill it. And it makes sense. Like if you're not using it, why should it be communicating, right? And this could be a feature that could be turned on and off. It doesn't have to be on for everybody, right? But if you are privacy conscious, you turn this thing on, right? And if the application is not in focus, it doesn't have permission to use the network. Right? That's an easy fix. It would take literally a couple of hours to implement this. The next item I have is a dormant tab that never sleeps, which is what I'm describing, right? You open the tab, you leave it there in the background for weeks, and you don't remember that the thing is communicating and using these weekend requests that the CPC exploits. The intentional HTTP 1 and 2 requests, sorry. On the HTTP3 capable server client channels, I described this before, and the convenient web email client, this is something that is related to what I was mentioning, right? So Gmail, right? It's so convenient. It has so many features that are good that you want to have this thing open all the time in the background. Right? And again, right, it touches more on the behavioral aspect of the conversation, but that creates an immense weakness because you see the amount of requests that this thing is doing on the background. Right? And you can see that here, right? After it renders, because I've worked in email clients before myself, right? And after it renders, it's okay if it makes one request to fetch new messages, but this thing is doing all these requests for things that look at that. Right? We're talking about dozens of requests, and I'm not doing anything with it. Right? But there's no way to control this. I mean, there's no regulation for this, right? The company is free to do whatever they want with their product. And if this creates these weaknesses that they get exploited by the CPC, there's no way to control that. So the only control you have is your behavior, right? How you use it, and if you're aware of what it's doing or not. Yes. So let me. Yes. So I have other things that I want to talk about, but because this session I think is getting kind of long. I'm gonna cut this one here, and I'm gonna make another session with other more. They're more about implementation of fixes that I've done myself in my systems. So these are the things that touch less people, right? That this would be useful for less people, but it would be useful for engineers that want to develop solutions to counter what the CPC is doing, right? And I think at the end, right, when this information becomes public, I think what will happen is that, or what should happen, right, is that a group of people interested in these topics of cybersecurity and privacy should probably start developing solutions at a scale that counter what the CPC is doing now that what the pattern of attacks is known, right? Because the advantage they had until now is that nobody knew they were doing this at planet scale, right? With this level of sophistication. But now that it's known, right, what is needed is a group of people to rise to the occasion and develop solutions at a scale to counter all these weaknesses and to proactively mitigate them at the highest level of aggregation possible. Meaning, the ICANN, the DNS servers, all these aggregators that they exploit to do all these things. Anyhow, I thank you for your time today, and I'll see you on the next one.